Okay, so let's talk about performance monitoring. Now, I'm going to do this on a Windows Server, although it works the exact same way on a Windows client system as well. One of the benefits of them sharing the same kernel. Okay, so performance monitoring is one of the things that we do a lot because one of the most common complaints we ever get is the system's running slow. So we need to find out why, and that's where performance monitoring comes in. Okay, so let's start with Task Manager. Now, there's like a million different ways to start Task Manager. Because I am on a VM, I'm going to just open up Task Manager by searching for Task Manager. There are also hotkeys that'll open up Task Manager. Control Delete, go to Task Manager. I'm going to open it up this way just to get to it without having my host PC pick up those hotkeys. All right, so Task Manager, this is going to show me all my running apps, and there aren't any at the moment, but this isn't the screen that I want anyway. I want to go to more details. Now, this is going to show me right here my CPU usage in percentages and my memory usage in percentages. So I'm using 71% of my memory and then 3 to 5% of my CPU. All right, cool. A little more information is actually going to come from your Performance tab. So on my Performance tab, I can see CPU, I can see memory, and I can see Ethernet usage. The processes is going to let me sort by CPU or by memory and see who's using the most. So that becomes kind of beneficial because if I'm using a lot of CPU or memory time, or on a physical computer, I'm also going to see disk usage and that as well. I can sort by who's using the most, and I can see what's causing my slowdowns. On the Performance tab, I see more of this overall view of it. So here's my CPU utilization, number of processes, number of threads, number of handles, base information. On my memory, it's going to show me the amount that I have in use, what's available, my committed, my cache, my page pool. So one of the things that I want to make sure here is that my committed does not exceed my physical memory. The committed memory is how much memory is it taking to keep the system up right now. So it's showing 1.7 out of 2.6 gigabytes. So what that means is I have 1.7 gigabytes of memory that's required just to keep the system operating at this point. You see my commit limit here is 2.6. Now you'll notice that's going to be different than this up here, 2.2. It's because the committed includes this page file. Big thing here is if your committed goes over your physical memory, then you're having to use the swap file nonstop just to keep the system up and running. And that's bad because swap file means I'm reading and writing to my hard drive a lot, and my hard drive is the slowest component of my computer. So if committed memory goes over physical memory, you either need to move workloads off of this, so move applications around, make it so that this one's doing less to lower those memory requirements, or you need to give it more physical memory, one or the other. With CPU, CPU is going to jump around a lot. If it stays above about 70%, you're going to notice slowdowns. If it spikes occasionally up to 100%, that's normal. You just want to see it drop back down. It's when it stays up above a fairly high percentage that it becomes an ongoing problem. And again, our options are move workloads or add processors. All right, if I want more detailed information, so this gives me a real quick right now snapshot. If I want more detailed information, then I open up the resource monitor. And the resource monitor, maximize it here, this is my general overview. So I have CPU, disk, network, memory. If I have multiple CPU cores, and I'm running a VM with only one, so I only see one CPU core here. If I have multiple, I might see multiple CPU cores. If I want to dig deeper into each one of these, I can go to my CPU. So this gives me my total CPU, my service CPU usage and unlike the task manager, when you're looking at performance information, you'll see here that I have different processes, the number of threads they're running, the average CPU usage, and again, all of these are sortable. Now this is going to give me my average CPU, not just my instant CPU usage. And that becomes really, really helpful when I want to look back and see, all right, who has been using the most CPU. Task Manager will only show me right now. Resource Monitor will show me right now, but it'll also give me a little bit of an average for a while, and that becomes really beneficial. Memory, I'm going to see my used physical memory, my commit charge, and then here I'm going to see what's in use, what's modified. Now something that's modified is something that has been changed but it hasn't been written to disk yet. It's normal to have some of that. But here's the other thing. This says I have 2 megabytes of free memory. That's actually not true, because I've got this 527 megabytes of standby memory. So let me tell you what the difference between these is. In use is something that I have in memory that I need to have in memory for what I'm doing. Standby is a performance thing. So the operating system takes a guess as to what I need or what I'm going to want next, and then it loads it into memory. So if it guesses right and I use what it thinks I need, it can load it out of memory rather than having to load it off of hard drive. So that's sitting there in standby in case I need it. But if I do something else, it'll drop that immediately. So it's an instant drop, gone, not worried about it anymore. And so my available memory is actually my standby plus my free memory. This is just, I'm preloaded just in case you might need this. And it's an attempt to boost performance. So for each one of these, we're going to see hard faults per second. We'll talk about that in just a second. The committed, the working set is what we're working with at this moment. How much is shareable? How much is private? Probably one of the most important things here. Now this is going to give you how much memory is this process using. And again, all of these are sortable, right? This is going to give me how much is this process actually using. But one of the most important things performance-wise is going to be right here, hard faults per second. So what a hard fault is when I requested something from memory that wasn't there. And if it's not there, it's got to go back to the hard drive to get it. And remember, the hard drive is the slowest component in the computer. So the more often I have to go back to the hard drive, the slower my system runs. And that's what those hard faults are. Now this shows me how many hard faults I have per second. And the more hard faults I have, the more I'm having to go back to the hard drive, the slower my system is running. So this right here tells me if I need to add more memory. This tells me if I'm having a negative impact on my performance because I don't have enough memory. Now, if I'm getting a lot of hard faults per second, well, I can add more physical RAM. That's going to be beneficial because that's going to mean more that I can store in memory, so hopefully less that I have to go back to the hard drive. Other thing I can do is I can try to speed up my disks, so I can put them in a RAID array, or I could upgrade to SSD or NVMe or something like that to try to speed it up. Your best, most cost-efficient approach is probably going to be to add more memory. All right, let's go to our disk. So our disk, this is going to give us disk usage. And you're going to see a couple of things here. So this is my disk usage. Now this looks dramatic. Ignore the graphs here, okay? The graphs are only useful for comparing against, 10 seconds ago. So this is my disk transfer rate. So this is 100 kilobits per second. So you see I'm using very, very little disk time here. The one that I'm going to care about more is this one right here, which is the disk queue length. Now, the disk queue length is how many processes are waiting for disk time, but they can't have it. So, process 1 is reading and writing to the disk. Process 2 wants to read and write from the disk. It can't because process 1 is doing things, therefore it's queued. And then process 3 wants to read and write from the disk. It can't because process 1 is reading and writing. Process 2 is already queued, so process 3 becomes the second person in the queue, or the second process in the queue. So a disk queue length means processes are being slowed down because they can't even get to the hard drive because something else is getting to the hard drive in its place. All right, so that is our disk queue length. We want a disk queue length of less than 2. Now notice we've got a couple of spikes here in disk queue length, but again, look at the numbers here. This is on a scale from 0 to 0.01, which means we're not really having spikes. So our disk queue length is pretty good. Closer to 0, the better. If and it'll always be a little bit above 0. But the closer to the 0, the better. If it gets above 2, you're probably going to notice some pretty significant slowdowns. All right, so how do you deal with it? Option number 1, move workloads. Is there something that's using a lot of disk time? If I have two things that are using a lot of disk time, two processes, and right here, this shows me my processes that are using the number of bytes read per second, number of bytes written per second, total bytes per second. If I have two things here that are using a ton of disk time, and it's pushing my disk usage up here, and my disk queue length is coming up, in that case, I might want to move one of those workloads off to another server. It's option number 1. Option number 2, use RAID. So if I can move this off to a disk that's rated, then I'm going to read and write faster, which means people are going to spend less time in the queue. Same thing with putting in SSD or NVMe drives, or even better yet, RAIDing SSD drives. So that's going to give me some better performance because I'm going to have less time that it takes to read and write, which means I can move through these things faster and get to the people in the queue quicker and clear out that queue faster. The other thing I could do is I could put in an additional physical drive. Now, taking a physical drive and dividing it up to a couple of partitions isn't going to change things because it doesn't give me any additional heads for reading and writing. So, if I add an additional physical drive, then I can move some services off to that additional drive, have them store data on that different physical drive, and that's going to help quite a bit because now I have different heads that people are reading, that processes are reading and writing from. Okay, network. What we're looking at here with network. Now, again, these graphs make it look way worse than it is. It's like, oh my gosh, we're maxed out. No, this has to do with the number of TCP connections we have per second. And that's on a scale from 0 to 20. So, and it just adjusted from 0 to 50. And so you can see, wow, this looks better now. All right, so this is my network. And this shows me my network traffic. However, notice that this is up to 10 kilobits. So again, we got to pay attention to these scales because in reality, we're not actually using much time. As we see down here, our Ethernet usage from 0 to 100% isn't even registering. So, what happens if my network starts to become my slowdown? That is actually, of the 4 components that will slow down your system, processor, memory, disk, and network, that is the least likely one to create a problem for you. The most likely one is going to be your hard drive, followed probably by your memory, then your processor, then your network. However, if it does become an issue and your network is slowing down, and probably if you see the Ethernet percentage down here up above about 60 or 70% on a regular basis, you're going to start noticing some slowdowns to the network. So option number 1, move workloads. It's amazing how we keep coming back to that. Option number 2, upgrade your Ethernet card to a faster Ethernet card. And make sure your switch can handle that as well. Option number 3, put in an additional Ethernet card, or if your system has more than one already, use a NIC team to tie those together to increase your bandwidth. NIC teaming will bond multiple Ethernet connections into a single logical connection, and it will increase your bandwidth, and that will help out quite a bit. Okay, so we've looked at Task Manager, we've looked at Resource Monitor. Both of these are great, but both of them are kind of showing me current information. They're not showing me historical information. So for that, I need an additional tool. And that tool is going to be our performance monitor. And so I'm going to search for PER, and here is my performance monitor. Now, your performance monitor allows you to build data collector sets. And this is really cool because I can create a data collector set and I can have it run at specific times. Now, I can also use existing monitoring tools. So here's my performance monitor. And right now, I have one thing in my performance monitor, which is my percent of processor time. So let me add something else. I can add an additional counter by coming up here, clicking add, and this is going to list all of my counters for me. And there are a bunch of them, and it is going to vary based on what you have installed on your system because most Microsoft applications will put in their own performance counters. So see right here I have processor. If I click my drop down, here are all of my processor counters. %C1 time, C2 time, idle time, and you'll see a whole bunch of these. Now let me do % idle time just for the fun of it. Let's do % user time. That'll be a little more entertaining. So I pick the counter that I want here, and then this tells me which instance. Do I want my total % user time? Do I want all instances? Do I want on processor core 1, 2, 3, 4, 5, 6? What do I want? So when I have selected what I want, I'm going to click Add, and then OK. So now I have two counters. And luckily enough for us, both of them are red. So % processor time, % user time. So I want to change this, and I can click to show or unshow any of these just by clicking that button. I can also modify this. So let me come up to, well, that's going to allow me to highlight. Let me right click and then properties. And I want to change my user time from red to blue. And so now here you'll see I have red and blue lines running across. Now notice this again is showing me for about a minute of historical time. By the way, before we jump in, before we jump on to the next part, let me also show you I can add any number of counters here from just about anything. And there are millions of them. So let me find physical disk. And I want to look at my physical disk, and I want to look at my % of disk time, and I want to look at my % of disk time for C drive. And then I'm going to add that. And I can add multiple things here before I hit OK. So I'm going to hit OK. And my % of disk time, well, this is showing in yellow, and that kind of sucks. So let me go to my properties. I'm going to change that from yellow to, let's do green. And so now, let me hide my other two, and you'll see just a little bit of green from my physical disk time. Okay, the other thing we can do with this is we can change the scale. And this is going to be really useful. Let me try to change the scale up to by a factor of 10. And so now we're going to see that green stand out a little bit more. Now, again, we got to be aware of scales. Otherwise, we're going to say, oh, we had a huge spike here in disk time. Well, actually, we had a very minor spike there in disk time. So always remember to verify the scales when you are looking at these. Now, this again is showing me information for right now. But what if I want to know at a different time? So let's say my system seems to be running poorly at a time when I can't necessarily be sitting here looking at it. Well, that's what the idea of a data collector set is. Now we have some data collector sets already predefined. Blow this up and give us a little more room. So I have system diagnostics and system performance, which are both data collector sets that are already predefined. And then I've got one here that doesn't have a name. All right. Or I can create my own user-defined data set. So I can right-click New Data Collector Set. And I'm going to call this Temp. And I'm going to create it manually. And then I get to choose what type of data do I want, performance counter, event trace, or system configuration, or all of the above. Performance counter alerts. What that will do is that'll be something that's running in the background. So I can create a performance counter alert that says anytime my disk queue length gets above 2, send me an alert. Or anytime my physical memory usage gets above 90%, send me an alert. That's what those alerts are. But let's take a look at the data logs for the moment. So I want to do performance data logs and click next. Then I'm going to add performance counters. And I have all the same counters. So I'm going to add my total processor time. Whoops, that included all of my processor. I didn't want that. Let me do my percent processor time, total, add. And then I want my physical disk. And I'm going to add my physical disk percent disk time for everything. And then I want to add my average disk queue length. And I'm going to add that. And then let me find memory. And let me do percent of committed bytes in use and add. So now I've got 4 different counters here. Let's do cache faults per second too, just for the fun of it. Okay, and then I'm going to hit OK. Sample interval, how often do I want this to sample? So I'm going to say that I want this to sample every 3 seconds. And next, where do I want it to be saved? I'm good with that. I'll click Finish. And now I have a performance counter, data collector set. There we go. Data collector set for performance counters named temp. Now, anytime I want this, I can right click and start. And that's going to start capturing that data for me. And you're going to see right here, I have my start is grayed out. It's currently running, and then I can stop the data collector set whenever I want. So I'm going to give it just a few more seconds because we told it to do this sampling every 3 seconds, and then I can stop the performance counter. Now, that captures that data for me, and that's going to be here under reports. And here's my temp, and it's going to give me my name, the server name, and the date. And this is the first time I ran this, so here's my report. And that's going to give me my report of everything I'm using. And my gosh, that yellow doesn't show up well. So let's go ahead and change that because we can. Let's change our color to... That looks good. All right, and now I have my data. Now, I can view this in graph format. I can also look at specific numbers here. So let me look at my percent disk time. So that's going to be my little green thing right here, my little green line. And I can see the last, the average, the minimum, the maximum, and then how long this ran for. So over 21 seconds, this was the chart of my performance. So I can use this now to capture information and then come back and review it later. The other really cool thing about this is I can right click on my data collector set. I can start it. I can look at my properties of it and modify it. And here's the best thing is I can schedule it. So I can say this is when I want you to run. And if I set that, it'll run at that time when I've set it. It will capture data, and then I can come back and review it later. So I can, let's add a schedule here, and I can set beginning date, ending date, start time, which days it runs. And I can use this to track my performance even when I'm not there. So I can be off doing something else, or I can be physically not on site. And I can use it to capture all of that performance information and then come back and review it later. And this will give me historical performance information, unlike Task Manager and Resource Monitor, which only give me current active performance information. All right. So hopefully, let me bail out of there. Also notice, by the way, when we're here, we have a stop condition. So when I start it, what's going to cause it to stop? I can set up for a specific period of time or specific limits. Once we get to a certain size, stop collecting, and then I can have it run its scheduled task when the data collector stops. So I could have it copy that log file over somewhere else, or I could have it whatever I wanted to do. Any task that I had, I could have it runs this information and then, or capture this information and then do whatever it is that I wanted it to do. So I have my schedule or task, the task arguments, and then user text. So I'm going to go ahead and cancel this, and hopefully that gives us some tools to start tracking and monitoring performance on our Windows systems.